All right. So today we're moving on, and it's a combination of everything that we've been doing this week, and we're going to talk about series. I'm not sharing my page. Huh. That would help. There we go. Okay. Oops. Give me 1 second. That's not supposed to be series. Okay. So consider an infinite sequence, A1, A2, A3, dot, 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 goes on forever. It's infinite. So we say the sum of the first n terms is a finite series. Okay, so we have an infinite list of numbers, but we're not considering all of them. We want to stop somewhere. We want to stop after n terms. So once we stop, that becomes finite. It's not infinite anymore. So when we add them up, when we find the sum of those terms, we call that a series. Okay, it is a finite series, also known as the nth partial sum. Right, and again, we have that name nth because n is just like a placeholder for whatever place we want to stop at. It may be the 5th term, it may be the 20th, it may be the millionth term. We don't know. All right, so the sum of all those, A1 plus A2 plus A3 plus all the way up to wherever we want to stop, right, is this here, sigma from 1 to n of AI. Right, and we saw that yesterday when we started talking about sums. And I also mentioned this yesterday. If we add up all the terms, we call that an infinite series. Right, and the only difference there between this and this is our upper limit is infinity instead of whatever number we choose. Now this, I mentioned yesterday, has some very special cases. If my sequence is just numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that goes on infinitely, then I can't find the sum of that. Right? I can't keep adding numbers infinitely and stop somewhere. Right? Because as soon as I add a new number, it gets that much larger. But there are a few special cases where we can find the sum of an infinite series. And I'll show you some examples in a second. I want to make sure you guys get all this. All right. Let's look at some examples. Okay, so we'll do both for this, for the partial sum and the infinite sum. So we have the series from 1 to infinity, right? So that just tells us that we're dealing with an infinite sequence of 3 over 10 to the I power. So first we want to find the third partial sum, and then B, we want to find the sum of this series. All right, so when they say the partial sum, that's telling you you're going to replace the infinity with whatever number that they tell you that you're looking for. So for the first one, we're going to go from 1 to 3 of 3 over 10 to the I power. Let me make that look a little nicer. 3 over 10 to the I power. All right, so this is only 3 terms, so this isn't too bad. So let's write it out. So first I'm going to have 3 over 10 to the first plus 3 over 10 squared plus 3 over 10 to the third. And that's where I'm going to stop because that's my upper bound, the 3 there. All right, so 3 over 10 gets me 0.3. 3 over 100 gets me 0.03. 3 over 1,000 will get me 0.003. So the third partial sum is 0.333. Right, so that's pretty straightforward, right? You're just calculating that. Right, 3/10 plus 3/100 plus 3/1000. Now, maybe you can see kind of where we're going for the entire sum. All right, so let's take a look at our infinite sum. All right, so the sum from 1 to infinity. Now, obviously, I'm not going to write out all the terms because there's an infinite amount of them, but we'll write out the first few. All right, and I'm just doing the exponent part already, so all right, this is 3 to the first, 3 to the second, 3 to the third, 10 to the first, 10 to the second, 10 cubed, 10 to the fourth, 10 to the fifth. And guess what? It's going to keep going on forever. But what happens, right, if you notice the pattern that we had up here, right, this is going to get me 0.3. This is going to get me 0.03. This is going to get me 0.003. Right, usually there's some sort of trend that you can follow. Right, and if that keeps going on forever, that's going to get me 0.3 repeating, which is 1/3. Right, so the sum, an infinite sum from 1 to infinity of 3 over 10 eventually adds up to 1/3. So it's pretty interesting, I think, because we get an infinite string of numbers that adds up to some fraction that's less than 1. Right, so usually, okay, I don't want to say always, but usually if we're dealing with a series with fractions, then we can find that infinite sum. Okay, like I said before, if this was just maybe 3 to the I power with no fraction part, with no denominator, well, then that would be impossible. I could find the third partial sum, right? 3 times 3 squared plus, 3 to the third plus 3 to the fifth, whatever. But when it comes to the infinite part, right, that's where we would enter some problems. Right? Any questions about that? All right, let's look at two more. All right, so we're going to do the sum from k equals 1 to infinity of 1/10 to the k power. All right, so what we're looking for is we're going to do the first couple terms, but then we're going to look for some sort of pattern that hopefully connects us to our answer. All right, so if I just write this out, all right, k is my index now, so it's just replacing the I, same process. So first I'm going to have 1/10. Oh, stop doing it. 1/10. No. 1/10 to the first plus 1/10 squared plus 1/10 to the third plus, I'll do 4. No, not 4. I said 4. All right, so hopefully we can find the pattern before we have to add too many. All right, so this is going to get me 0.1 plus 0.01 plus 0.001. So similar to last time, right? I forgot a 0. All right, so this is going to get us 0.111111111 repeating, right? So, it may take a little bit of critical thinking, but what fraction gets us 0.1 repeating? Okay, and that's going to be 1/9. Right, so making that connection from the repeating decimal to its equivalent fraction, you might just need some practice with that, and it's just, you get to recognize it eventually. But yeah. All right, so now let's take a look at another one that's slightly different. And we're actually going to use one of the rules we learned yesterday. All right, so we're going to find the same partial sum, but now we're multiplying it by 7. I have a constant or a coefficient of 7 on the outside. Now, one of the rules we learned yesterday is anytime we have a constant, I can remove that to the outside. As long as there's no, k attached to it, I can just move that to the front. Right, so I just took that 7 and I put it on the outside. Well, we already figured out that the sum from 1 to infinity of 1 over 10k is 1/9. So I'm going to substitute 1/9 for this. And my answer is just going to be that 1/9 times that coefficient I had, 7. That's going to be 7/9. All right, so we can use, those tricks, those properties that we learned yesterday in combination with, things that we already know, and it makes things a little easier for us, right? Instead of me writing 0.7 and then 0.07 and 0.007, and then trying to figure out, well, what does 0.7 repeated, what does that equal? Well, I use the fact that I know that 0.1 repeating is 1/9, and then we just multiply that by 7 to get us 7/9. All right, any questions about series and sums? I know this is all pretty new material, so I don't want to move too fast. All right, so we're going to end it there today. I don't want to carry on any further and get you into, you know, brand new material. So what I'm going to do is I'm going to give you guys tomorrow the day off, unless you have work to make up. Right. Today's the last day of the marking period. So, you know, I'm not assigning anything new for this week, but please make sure any of your missing assignments are completed. You know, I tell you all the time, the answers are there. All right. They're in the videos. You just got to find out when the due date was and look up that day's video. You know, if you're struggling. I do believe I sent you an email if you owed me a lot of work. If you only owe me 1 or 2 things, I didn't send an email yesterday, but you know what you're missing. It's on Google Classroom. It's all up there for you. If you're unsure, shoot me an email. I'll let you know if you owe me anything. All right, guys. So please, please, please use tomorrow to make up any missing work. And then Monday, we're going to hit the ground running with a continuation of what we're doing here. All right, guys. So I'll be here tomorrow during class, as always, if you want to stop by for help or just to say hi. Otherwise, have a great weekend, and I'll see you all on Monday.
Thank you.